In this lecture, we are going to learn about pixel relationship. So basic relationship between pixels are neighborhood, adjacency, connectivity, paths, regions and boundaries. So matrix elements are called pixels. So we found that some important relationship exist among pixels. A person who is living next to me is called neighbor. Similarly, the pixels who are close to each other are called neighbor pixels. A pixel P at location x comma y has two horizontal and two vertical neighbors. This set of four pixels are called four neighbors. So this is called x plus 1 comma y. This is x minus 1 comma y. This is x comma y minus 1 and x y plus 1. So these four pixels are called four neighbors and that is denoted by N4P. Each of these neighbors is at a unit distance. There is a 1 pixel distance from P. If P is a boundary pixel, for example, if P lies here, then it will have less number of neighbors. Since if P lies here, then there are two vertical neighbors and one horizontal neighbors only. Now, four diagonal neighbors of P denoted by NDP. So these are the four diagonal neighbors. This one, this one, this one and this one. So that is x minus 1 comma y plus 1. This one is x plus 1 and y plus 1. This one is x plus 1 and y minus 1. This one is x minus y and y minus 1. So if we are going to combine these four diagonal pixels and four neighbors pixel, then they are called 8 neighbors of P and denoted by N8P. So N8P is equal to N4P union of NDP. If P is a boundary pixel, then both NDP means diagonal pixel and N8P will have less number of pixels. Now, adjacency. Two pixels are linked if they are neighbors and their gray labels satisfy few detailed pattern of similarity. For instance, in a binary image, two pixels are connected if they are four neighbors and have the same value of intensity, either 0 or 1. Let V be the set of intensity values. For example, V is an element of I. So for adjacency, two pixels P and Q with values from V are adjacent if Q is in the set of N4P, means 4 neighbor pixel. If Q lies in N4P. 8 adjacency, 2 pixel P and Q with values from V are 8 adjacent if Q is in the set of N8P. Now, M adjacency, which is also known as mixed adjacency, that eliminates the multiple path connections that arises with 8 adjacency. So in M adjacency, 2 pixel P and Q with values from V are M adjacent if Q is in the set of N4P, that is a 4 neighbors, and or Q is in the set of NDP and the set N4P intersection N4Q has no pixel whose values are from V. So there is a path relationship between the pixel a digital path from pixel P with coordinates x0, y0 to pixel Q with coordinate x of n, comma, y of n is a sequence of distinct pixels with coordinates x0, y0, x1, y1, comma, dot 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 x of n, comma, y of n, where x of I, comma, y of j and x of I minus 1, comma, y of I minus 1 are adjacent for I lies between 1 to n. Here n is the length of the path. If x0 and y0, comma, y0 is equal to x of n, comma, y of n, then the path is closed path. We can define 4, 8 and m paths based on the type of adjacency used. So in the present example, we assume that V, which is the value of intensity, is equal to 1 comma 2, means 1 comma 2 is an intensity values. So in the first part, we can establish a pixel relationship, that is adjacency, between this. So 1 comma 2 belongs to I. So there is a path from 2 to 1. There is a n for P. Means they are 4 adjacent because 1 is the neighborhood, vertical neighbor of 2. And now this one is also a vertical neighbor of this one. Sorry, horizontal neighbor of this one. But even though this one belongs to V, but this one is not a neighborhood pixel of either this 2 or 1. So this satisfies 4 adjacent and we can find a path between them, 2 to 1 and 1 to 1. Now in the second case, this one is a 8 adjacent condition. They satisfied 8 adjacent condition. So this 1 is a neighborhood pixel of 2 and this one is also a neighborhood pixel of this one. Now this one is a satisfied NDP. So this one is satisfies the diagonal condition or N8 condition and this one also satisfies the N8 condition. But there are 2 paths to reach from 2 to 1. One is this one from 2 to 1 and then 1 to 1. Another one is 2 to 1. So there is a diagonal path also. So there is a confusion because there is a multiple path to reach this position. So to avoid this one, we have to go for M adjacent. So this one belongs to this neighborhood of 2, so there is a path, and this one is also a neighbor of this one, so there is also a path. Now for example, this one belongs to satisfy N8 condition, so there is a path, and there is only a single path because this 0 and this 0 does not belongs to V. While here, as we can see in the 8 adjacent path, there are 2 paths. From 2 to 1 there is a diagonal, and from 2 to 1 and then again they are 1 to 1. So now what, this is not an N4 P of this one. So this, if it is a P, it is a Q. If it satisfies, Q is the set of NDP and Q is in the set of NDP and the set N4P and N4Q has no pixel whose values are from V. So now we can find this one is a P, this one is a Q, and N4 of this one is 1 and N4 of this one is a 1. And this one belongs to V. But this is also a N4 of this Q pixel and this is also a N4 of this P pixel. But that 0 does not belongs to V. So there will be a no adjacent path. So it does not satisfy the M adjacency condition. Now connectivity. Let S represent a subset of pixels in an image. 2 pixel P with coordinates x0, y0 and Q with coordinates x of n, yn are said to be connected in S if there exists a path. So x0, y0, x1, y1, dot dot x of n, y of n. For every element of I lies between 0 to n, x of I, y of I is an element of S. Let S represent a subset of a pixel in an image. For every pixel P in S, the set of pixels in S that are connected to P is called connected components of S. If S has only one connected component, then S is called connected set. We called R a region of the image if R is a connected set. Two regions Ri and Rj are said to be adjacent if their union forms a connected set. Regions that are not adjacent are said to be disjoint. The boundary of the region R is the set of pixels in the region that have one or more neighbors that are not in R. If R happens to be an entire image, then its boundary is defined as set of pixels in the first and last rows and columns of the image. Now foreground and background. An image R contains k disjoint regions Rk. K varies from 1 to capital K. Let Ru denote the union of all the k regions and R of U complement denotes it complement. Then all the points in the R of U is called foreground and all the points in the complementary of R of U is called background. Now distance measurement. Given a pixel P, Q and Z with the coordinate x, y, s, t, u, v respectively, the distance function d has following properties. That distance P, Q is always greater than equal to 0. If P is equal to Q, then distance is 0. If P, Q is equal to DQ, P, then it must have some symmetry. Otherwise, D of P, Z is always less than D of P, Q plus D of Q, Z. Otherwise, D, P, Z is always less than equal to D of P, Q plus D of Q, Z. Now, the following are the different distance measures. First one is Euclidean distance. So D of P, Q is equal to under root of x minus s ka square plus y minus t square, where set of points S is equal to Q for every element D of P, Q is less than equal to R. Are the points contained in the disk of radius R centered at P. Now next one is city block diagram. It is also known as Manhattan distance, where D for P, Q is equal to mod of x minus s plus mod of y minus t. Points having a city blocks having from P less than equal to R form a diamond centered at P. So from here to here it satisfied unit distance. Now if you are going towards diagonal, then we have to 0, this one is a -1, comma +1. So the distance is 0 minus 1 and 0 plus 1. So overall the distance of mod is 2. Now next one is a chessboard distance. So chessboard distance d8p comma q is equal to maximum of x mod of x minus s comma y minus t. It forms a square centered at P. So this one form a square, then another square, then another square. So these are some references. Thank you.